You're welcome. Thank you very much, and welcome to Son of Fun. Before we get going here, what I like to do is remind you that whenever you see one of these gentlemen walking around with one of those blue shirts, these are the volunteers. These are the people that are behind the scenes that makes possible these presentations to go on. And I really think they do a tremendous job. They give of their time, money. So I think they deserve a good round of applause. How about that? The topic today is going to be stall spin prevention and survival. Although I'm going to talk very little about spins, the core or the meat of the presentation is going to be about stalls. Because if we are good at stalls, the chances of us getting into a spin are nil. And I've been researching this for quite a while now, for about five to 6 years. And one of the things that got me into this was the fact that I, myself, was a I was a pilot that was always apprehensive about stalls. And, you know, they conducted a study about this, and they concluded that 99% of pilots are afraid of stalls at some point. And the other 1% are liars. So because of that, I was also in that group. And it was probably until I got my instrument rating that my instrument instructor really cured me of the stall spin apprehension syndrome, I guess. I remember that even when it was windy, I wouldn't even fly because I heard somewhere that a gust of wind can induce a stall. You stall, you spin, you crash, you burn, you die. I don't want to go there. So I was about 140, 148, because back then you had to be 200 hours before you can go for your instrument rating. And it was about that much that I flew without problem. So it's good that you're here. And like I said, the whole presentation is going to deal with the fact that we need to work on stalls. Okay, that's my email address. If you write that email address and you have any questions of any kind, you can go ahead and email me, and I will answer all your questions. And I really do encourage questions because that's how I learn, however. If you ask me a question I don't know the answer to, well, I'm going to research it, and therefore I'm going to learn too. So I strongly recommend it. When you do that, however, the reference you read safety seminars, because I don't open up everything that I get. I take constructive criticism very well too. So if you email me and you see something that could be changed or could be better or could be added to, please do. I really encourage that. If you have any flying stories, whether funny ones or serious ones, I will also encourage you to share those with me. One of the things, well, all my presentations are copyrighted, and you can use it and all that kind of stuff, whether you're a flight instructor or not. Stall spin prevention and survival. Before we get into the meat of things, there's a few things that we need to know. And these are things that may hurt you. I found out through experience that what we need to know but haven't learned, and usually is some basic knowledge, usually something that we should have learned somewhere along the line. And you know, this country is the father of practicality. You know, I'm a foreigner myself. It may be shocking to you. You probably detect a little bit of an accent here. I was not born here. I'm American by choice. This is the father of practicality. This is so practical that you can get your private pilot certificate if you want to in a month. Well, you cannot do that anywhere else because of all the things that come into play. But one of the things that are good but also bad is the questions and answer book. See, the reason why we have questions and answer books for our tests is just for one thing. It's to help us pass the test. It's not to make us knowledgeable. Yes, we're going to pick up some knowledge from that, but that's not knowledge enough. And sometimes we stop there. Oh, I got a 98. I got 100. I'm good. Well, yes, you do, but you need to understand that most of those questions do not address the whole issue. It's just a little part. And they took that question and they have a right answer for that question, but the fact that you know that answer doesn't necessarily mean that you know the complete scope. And sometimes, in the name of simplicity, we sacrifice accuracy or the fundamental knowledge that we really need to know about all these things. So this is something that we need to beware about this. Also, what we once knew but don't remember now. And remember, the process of forgetting begins when you finish that check ride. The minute you walk out on your way home from that check ride, the process of forgetting is taking place. Whether it's a check ride, whether it's your written test, whether it's your IFR, your IPC, your BFR, whatever it is, the minute you walk away from there, the process of forgetting starts to get in there. So we need to understand that. Now, also what we know and remember, but we cannot proficiently and readily execute. That's a bad thing, because we know it, but we're kind of rusty. We need to identify those areas and take care of that with training. And what we don't know, but we think we do. I think this is the worst of them all, because we're so sure that we know this thing, but yet we really don't. And as you see, as we're going to go through the process of this presentation, you're going to see where the holes are in the stall spin situation. My motto is that you show me a pilot that can't perform a given task, and I show you a pilot that doesn't understand what he or she is trying to do. Remember, the bottom line here is understanding. If you don't understand something, you're not going to be able to do it. So we need to spend time reading about things and talking with instructors about things. But we don't like to talk, and we don't like to read normally. What we like to do is to fly. And flying along is not the answer. You know, like when Walt was introducing me, you know, and they always say, you know, how many hours you have. And I toned that thing down because I don't want to really believe that. The reason being is experience is not an antidote for accidents. See? At what level of experience we don't crash anymore? Is it 5,000, 10,000, 15? There are 20,000-hour pilots crashing today. So that experience really doesn't mean a lot. Proficiency and knowledge, however, yes. That means, and the application of basics, which is all I'm going to talk about today is just about basics. I did a check ride for this lady. She's a doctor. And she came up with this. And I asked her if I could use it on my seminars. And it hit me like a ton of bricks. The eye can't see what the mind doesn't know. It's just that simple. If it's not in there, you're not going to be able to recognize it. So I hope that by the end of this presentation, you have a clear-cut picture about stalls. And now, this presentation alone is not enough, because we cannot do in 45, 50 minutes, you know, what it really takes about 8 hours to cover. But I took the important issues and put it in place. And, of course, we're talking about subsonic aircraft. Talking about 172s, Cherokees, Seminoles. We're not talking about F-16s. I'm not going to talk about compressibility stalls and all that big stuff. Just the things that are our level, you know, the things that are happening out there. So I'm going to be very basic. Some of you are advanced. Just bear with me, and I apologize. Now, this is what I call the training syndrome. When I started doing check rides, I realized that something was not right with the stall, the way the stalls are being taught, and the way we practice stalls. And so I call that the training syndrome, and I identify those areas. And I think we're missing the objective of why we do the stalls. Stalls is not just a maneuver that you do on a check ride. Stall means a lot of stuff that you're going to see as we go along. And then we're going to kind of cover why unintentional spins or stall spins occur. Now, how many of you know here, by show of hand, what a stall is? Show of hand. How many of you have done stalls? How many of you know how to recover from a stall? How many of you know how to identify a stall? Well, you know the scary thing about that is that if I ask those questions to all those pilots that have stalled and spun in, their answers are going to be the same as yours. That's the problem. If we know stalls, if we practice stalls, if we know how to recover from them, and we know how to avoid them, so we think, why is it that we get into a stall spin situation? That's what I am going to point out to you guys before we leave here. Now, let me ask this question. What is the stall speed in the clean configuration of the airplane you fly? I don't want nobody to answer. I want you to think. If you're thinking of a number right now, you're behind the 8 ball. And the reason why I do this is to show you the conditioning. We have the wrong conditioning about stalls. And you're probably thinking, okay, I fly 172, that's the wide arc. No, it's any airspeed. See, we need to think in terms that my airplane stalls at any airspeed, at any altitude. However, in a certain scenario, I can make my airplane stall at 40 or 45 with flaps, or at 60, 65 with no flaps. But that's a very controlled kind of environment in which I'm going to do that. Food for thought. Now, remember, this is one of the early definitions of stall. It says that if you push the stick forward, the houses get bigger. If you pull the stick back, they get smaller. That is, unless you keep pulling the stick all the way back, then they get bigger again. Because we're going to go down there. Now, there's also this, which it's taken a hold in our business. And I'll tell you, I think that this is what contributes to the fact that we think of stalls and airspeed. See, we never think of stalls and angle of attack. We think of stalls and airspeed. And this is one of the things that I really think has helped for that thought to cement in our brain. Maintain thy airspeed, lest the ground rise up and smite thee. We all heard this. Well, this is my version of that. This is exactly what the deal is. Do not exceed thy critical angle of attack, lest the ground rise up and smite thee. Because there's where it's at. You will never stall unless your angle of attack is not exceeded. I don't care how fast you're going. I don't care how slow you're going. If you don't exceed that angle of attack, you're not going to stall. If you don't stall, you're not going to spin. It's just as simple as that. Now, another thing that makes us apprehensive about stalls is the fact that we think of stalls as accidents. And probably the way they were presented to us in our training environment were not the proper way. Unfortunately, and in my case, I was presented to stalls for my second hour. And I'll tell you, when I came back from that flight, I was looking to buy a boat and go sailing somewhere because it plays an important role. That flight set up my idea of a stall, which was totally wrong, but that's what I thought. And I was that close of quitting because, actually, the instructor showed me a stall and spin. You know, when you go on an airplane with someone and someone else is flying and they say to you, watch this, I can guarantee you that something of entertaining value is about to happen. Guaranteed. And that's exactly what happened there. It goes, I have no idea what a stall was. I stalled and spun the airplane. Of course, when I saw sky, ground, I closed my eyes. And then when he recovered, he goes, what do you think about that? And I go, you're fired. Take me back to the airport. And I went away. I went away for about 6 months. But, you know, the bug was in there, and I came back. So maneuvers are not accidents. Stalls are not accidents. They're maneuvers. Now, why is it a maneuver? Because we enter a stall whenever we want to. We stay stalled as long as we want to. And we recover from that stall whenever we want to. So it meets the criteria of a maneuver. What happens is when it happens to you and you're not expecting it, then it becomes an accident. But if you are up on it, you're really not going to get to that situation because you're going to avoid. You're going to be treated as a maneuver. Another thing that I like to start putting in your mind is that we need to look at stalls as our friends. Stalls are our best friends. Do you know why a stall is your best friend as a pilot? You have any idea?
Hard to land without stalling.
Okay, that's right. That's one of them. But the most important one, the stall.
Keeps the wings alive.
Exactly. The stall prevents your airplane from breaking up. And here's the concept that I want to introduce to you. This is the concept that I want to introduce to you, is for you to think, what are you really doing when you're trying to stall an airplane? See, when you're increasing that angle of attack, what you're doing is you're building up pressure under the wings. And if the pressure that you build under the wing is such that the wind can take it, it's no problem. But when you exceed the pressure that the wind can take, that's when the plane breaks up. Fortunately, if you're flying at an airspeed that the airplane will stall prior to the wind coming off, nothing will happen. That's why the stall, I think of a stall as a safety valve. You ever see a compressor? If a compressor is going all the time and you see that, and it's set for 120 pounds, what happens when it gets to 125? There's a valve that opens up and goes psst, and allows that extra pressure to leave. That's what the wing does. When you're stalling that airplane and you stall, the wing says, there goes the pressure. I cannot take it anymore. And the airplane now goes back and you're flying again. So they are our friends. We really need to understand the stall. And like the gentleman said here, also, how can we land an airplane? The perfect way to land an airplane is to do a stall on a landing. That you stall 5 to 8 inches above the runway. And the airplane just sits on the mains, and that airplane will never bounce or balloon or anything like that because it'll stay on the ground. But you know why we don't stall on runways? This is another, I did a presentation last night about landing accidents in Tampa. And it's one of the things. You know why? Because we never achieve the landing attitude because we want to see the runway. If you're seeing the runway when you're landing, you don't have the proper altitude for landing. You ever see the shuttle land? Like this. You think that guy is seeing the runway? He's not seeing the runway. He's got clues around it, but he can't see the runway. He's coming in on the proper attitude. The same thing for us when we're landing airplane. Now, for those of you that are getting ready for check rides, there are no imminent stalls for check rides. There are imminent stalls for training. But all the stalls in the check ride are full stalls, whether the power off or power on. And there's a difference between the private stall and the commercial stall, in which the private stall, the recovery is initiated after the stall occurs. At a commercial pilot, the recovery is initiated as the stall occurs. So as and after. There is a play of words there, but it makes a big difference when you're doing that. Now, how many of you, and I don't want answers, but just look at this. How many of you have trained in all those different kind of stalls? Probably, I would say 90% of pilots don't get that kind of training. That when you get, the only time you're going to be aware of stalls and spins is when you go through that kind of training. What's happening today is that the PTS has been used as a training tool. And the PTS is not a training tool. The PTS is an evaluation tool. I'm doing consultant work. I've been doing consultant work, for the past 3 or 4 years, and right now I'm doing consultant work with true large schools, and this is one of the areas that we're addressing, where the PTS is an evaluation tool, it's not a training tool. What happens is the PTS is the tool that I use to evaluate. I cannot go outside of the PTS. In other words, I cannot ask a private pilot to do a cross-control stall. I cannot ask a private pilot to do an accelerator stall. But because I cannot ask him to do that, doesn't mean that the instructor shouldn't have trained him in those stalls. See, training is one thing, evaluating is another thing. So which is the training book? The FAA Training Handbook. That is the training book. And when you go into the FAA Training Handbook, you're going to find all those stalls in there. Only when you go through that series of stalls, you can say, now, how many of you fly a Cherokee 140, 180? NEPA 28, right? Now, if you're taking off from a short field, that airplane requires 25 degrees of flaps. Have you ever done a stall, power on your Cherokee with 25 degrees of flaps? Then, if you haven't done that, then you really don't know how that airplane will react when you're really coming out of a short field, loaded on a hot day, and 25 degrees of flap. Because that is totally what the mind, the eye can't see, what the mind doesn't know. So if you've never been there, you really don't know. You're now a test pilot, so to speak, because you've never done this on your own. Now, how many instrument radar pilots have done stalls under the hood? Good show. Spins. You can go ahead and, with an instructor, do spins under the hood. Get cured, like I did. I'm telling you, it's a totally different feeling. I was a miserable pilot for 158, 160 hours until and my instructor told me, he says, you know, you got to cure that because if not, you're never going to enjoy flying because that's going to be always in the back of your mind. And it was so true. After we went through the training and I realized that a stalled spin is a maneuver, something that I can do whenever I want to, then my whole attitude changed. And I really started to enjoy, not only enjoying aviation, but I think that I was 100%, 90% safer after that. Now, what I'm going to talk about here is about 4 angles. Two of those you're familiar with. 2 of those probably you're not familiar with because that's something that I came up with to really make the point of the stalls. The first, let's see. There's the angle of incidence. Most of you are familiar with that. The angle of attack. Most of you are familiar with that. Then we have the aircraft path angle. A lot of pilots are not really familiar with that. And at this school that I'm working with now, I had 27 instructors in this kind of session that we did, and it was amazing. They were just doing stalls, going through the motions of it, not really understanding all the little things that come into play. Now, and then we have the aircraft relative angle. See, and I'm going to explain each one of those to you. Angle of incidence is the angle between the core line of the wing and the longitudinal axis. Now we all know that that's an overgrown wing on that 172. Just to show my point there, that's your chord line. That's your longitudinal axis, and that's the angle of incidence. That angle, although exaggerated there, is fixed, and it comes from the manufacturer. And it, you know, all airplanes have to fly with a kind of a positive angle of attack. Very minor. It's already there so that we can fly straight on level. And also, this angle, however, has nothing to do with stalls. Has nothing to do with stalls because it's fixed. It's there. We don't see it. We don't see a mark. We don't see anything. Then comes the angle of attack. And by the way, on the angle of incidence, some manufacturers take one wing and they have a different angle of incidence from one wing to the other. You know why? You ever notice why when we're flying a cruise, we don't have to use rudders to take care of the left turning tendencies of an airplane? It's because one wing is developing a little bit more lift than the other wing. And therefore, it's a constant battle between this extra lift on the left wing and the left turning tendency of the airplane. They cancel each other out and we fly straight. If you fly a PA-28, the next time you go over there, stand in front of that airplane, you're going to see that the engine is not straight. It's set on an angle to the right. I believe it's about 3.5 to 4 degrees. So that when you're cruising, that engine is fighting the left turning tendencies of the airplane. Something to keep up there. So angle of attack is the angle between the core line and the relative wind. We all know that. We're not going to, it's just that simple. That's the core line, that's the relative wind, and that's the angle of attack. Very simple. And most pilot knows this, but we can't visualize it. See, we don't think about angle of attack, ever. We know what it is, but we're not conscious of it, especially when we're doing stalls or when we're in a situation where we can get into a kind of a bind. Now, the aircraft path angle is the angle between where the nose is pointing and where the airplane is going. And here's the problem that I find. The airplane climbs and moves forward. But somehow, and I've asked this question, most pilots think that the airplane climbs like this. You don't climb like this. You climb like this. In other words, there is a forward movement and also is an upward movement. So your angle of attack, even though you're climbing, it might be a little higher than it may be when you're cruising. Now, all this is setting up what we're going to talk about later. And a lot of pilots don't understand this. I'm not saying you, but through testing, I found out that it doesn't register. And it can't be seen. You can't see that. Now, this is the one, what I call the aircraft's relative angle. It's the angle between the longitudinal axis of the aircraft and the horizon. Think about it. The horizon and the airplane. I call that the killer angle. And the reason why I call that the killer angle is because the imprint that has formed in our brains as far as stalls is concerned is that view that we catch sometimes with our peripheral. And we know now that if I'm doing a power-on stall, my airplane, in order for my airplane to stall, it has to be like this. Because that's the way we're practicing the stalls. We go full power and we do this number. So we have already an imprint in our minds that the airplane, it is safe to be with an attitude as high as that. And still, I may be able to recover from the stall. But see, that's not how the stall happens at all. At all. The relationship of the angle, of the relative angle, in other words, the horizon to the airplane, has no meaning to the stalls at all. But it's dangerous because we're used to see that. We're going to cover that in a minute. Now, what is the aircraft relative angle good for? This is something that is happening today that is a lost art. Attitude flying. I see pilots now constantly chasing needles. VFR. You want to fly, you want to climb at 70, and they're glued to the airspeed indicator trying to get 70. They don't realize that the attitude of the airplane is where it's at. You need to know what is your climbing attitude that will give you 70 without looking at the airspeed indicator. Because what happens is when we're climbing, when we're going to set up the climb and we're looking at the airspeed indicator and we pull it back on the wheel, we're looking over here and we're doing 100 and we want 70. So we keep pulling up, but this needle is not reacting exactly at the same rate at which I'm exercising my attitude change. So when the airplane went past the attitude for 70, the needle hasn't gotten to 70 yet. So we keep pulling. Now the needle comes to 70, but guess what? Since the attitude now is higher than that required for 70, the needle is going to continue to show a slower speed. Now what do? We pitch down. Now the needle goes down now, and it becomes like a little game here. When really what you need to know is exactly where is that relationship between my airplane and the horizon. Whatever it is you use for a reference. It could be the instrument panel, or it could be the cowling, it could be anywhere or anything that you use for that. You need to know where that belongs for 70 on a climb. And then you look at the airspeed indicator to see if you set up the airplane correctly for the climb. Now you read, and the airspeed indicator is reading 80. You say, well, maybe I need a little bit more. So bring it up a little more, and then, got it, 70. Or the other way around. So attitude is a lost art. I'm telling you this. And for VFR flying, that's where it's at. Actually, for IFR flying, we do attitude flying. What do we call that little instrument there? The attitude indicator, right? Or the artificial horizon. Why? Because if you're going to climb in the soup, you just can't keep pulling that wheel back until you get to 80. You got to know where that little airplane belongs in relation to that horizon in that little instrument, just like you do on the outside. See, there's no mystery. The problem is this is not being taught. So now we are training in a way. I really believe that there are two kinds of pilots. There is a group of pilots that is always correcting for things. And there is another group of pilots that is always anticipating things. And it's okay to be in this group of always correcting for things. I was there. We start there. But we need to move to that group as soon as possible. But if we don't have the basic knowledge, the basic things that would allow us to go from this group to that group, we're going to be always correcting for things. And that's not a good thing. Because when you're correcting for things, that means that the bad thing already happened. You have to realize it, and now you have to fix it. Whereas if you're always anticipating things, before the bad thing happens, you can catch it. And that's that's the meat of this whole presentation here, is to make you aware of what could happen so you can fix it. All right. And it has no meaningful information about stalls either, because your attitude doesn't necessarily mean that your angle of attack is equal or parallel to that one. That's not the issue there. Now, we all see this. We all know about this relative angle, but we really don't understand. And that's where the problem is. Now, which airplane has the highest angle of attack there? Don't answer. If you're thinking of a letter, you're behind the 8-ball, because it doesn't matter. It just depends what each airplane is doing. Just because your nose is like this doesn't necessarily mean that your angle of attack is greater than the guy that is level. This guy is level, but with me descending at 1,000 feet a minute, so his angle of attack is almost critical. Whereas you're climbing and your angle of attack may only be 8 to 10 degrees. See what I mean? Now, determining the stall conditions. For testing, they come up with this, and that's how they arrive at these numbers that they give you, this VS and VSO and VS1 and all this. And I find that a lot of pilots really don't understand the process. Most of the times you're told, this is stall, and this is VS1, and this is VSO, this is what the airplane, but there's no explanation behind that. Therefore, we're just going through the motion of things. So starting from a speed at least 10 knots above the stall speed, the elevator control must be pulled back so that the rate of speed reduction will not exceed 1 knot per second until the stall is produced, as shown by either an uncontrollable downward pitching motion of the airplane, meaning, that's right, meaning that the airplane broke and you saw a definite pitch down, a downward pitching motion of the airplane resulting from the activation of stall avoidance device or a stick pusher. I mean, that's for the big airplanes. If you get to that condition, the stick will go, hey, dummy, lower the nose. We don't have that in our small airplanes. And then number 3 is the control reaching the stops. Sometimes I do check right. I don't mean to pick on people that own Cherokees, but they say to me, this airplane is very hard to stall. Why is that? Well, because I can go on the stall and look, I got the control all the way back and the plane doesn't stall. You're stalled already. If you have the control, look at the rate of, if you have the controls all the way back and that airplane is maintaining altitude or climbing, then you can be a millionaire tomorrow. But when that wheel is all the way back, you're in a stall condition and you're descending, even though you didn't see the brake. Because I'm going to tell you now another angle that we really, I would say 99% of the pilots don't know about. And see, an airplane evolves or moves, functions in an environment just like water. Same thing, it's a fluid. The only thing is water is denser and we can see it. Wind is less dense and we can't see it, but it's exactly the same thing. So the reason why when you are doing that stall and it seems to you that you held that elevator all the way back and the airplane did not stall is because the stall happened very close to the angle of buoyancy. Wow. Buoyancy. You know what that is? That means if I take an airplane and I stall the airplane and I don't recover from the airplane, I hold it in a stall condition, what do you think that airplane is going to do? Is the airplane going to go like this? No. The airplane is going to go like this. Correct? Because the airplane is now at its angle of buoyancy. The medium in which the airplane is and falling through keeps the airplane in that particular angle. If you stall the airplane like this and the airplane breaks there, the stall happens there, the airplane will go and search for the angle of buoyancy. And initially it'll overshot and then it'll come back, and if you don't recover, the airplane is just going to sit there and go down like this, all the way down. Are we together on this? Yes. That's why when you do a stall real smoothly, when you start pulling that wheel back, like if you don't want anybody to know that you're doing it, you're going to reach the angle of buoyancy very close. You're going to reach the critical angle of attack very close to that angle of buoyancy. Therefore, the airplane will not break because it's already there. And it'll just start to go down, stall, in a stalled condition. That's why when I hear that, people say, well, you can't stall this airplane. Look, I'll show you. Well, I'll tell you what, man, you can make a lot of money with this airplane because they haven't found one of those yet. So anyway, that is the definition of a stall. When the controls are full aft, you're stalled because you're going down. You're not maintaining altitude and you're not climbing. So definition of VS1. VS1 is the stalling speed if obtainable or the minimum steady speed in knots, calibrated airspeed at which the airplane is controllable with the engine idling, propeller takeoff position, airplane in the condition existed in the test for which VS1 is being used, and maximum weight. So remember, VS1 on your airplane meets that criteria for certification. If some of that stuff is not there when you're practicing stall, usually the stall will be lower than whatever the airspeed indicator says. Now, one of the things that I ask pilots sometimes, why do we do stalls? Why do we do a power-on stall? Well, one of the things you do power-on stalls is to really learn at what speed in that control environment that airplane stalls. Have you ever looked at the airspeed indicator when you're doing a power-on stall? If you haven't, you need to. You're going to see that it's going to be beyond, slower than the green arc. And you know why? Because when they gave you that number for VS1, the engine was idling. And now you have full power. So that creates extra lift and lowers the stall speed. If you fly an arrow, anybody here flies an arrow, you'll see that when you're going to do a short field takeoff, Piper, which is probably the only one that I've seen so far, in your takeoff graph, gives you a takeoff speed in relation to weight. Because remember, when you take off, if your airplane says that you take off at 70, that's a gross weight. If the airplane says, if you're flying and your weight is lighter than that, you can be slower than that. Because all those speeds are predicated at gross weight. In the case of the Piper, the VS1 is 61 in that condition. But here's what happened. When I'm doing a short field takeoff on a Piper, and I'm not at gross, and say I'm at 2,200 pounds, and I add that power, I also have 2 notches of flaps, which, what does the flap do? Lower the stall speed. Isn't that right? So now I have 2 things that I'm adding in there that are not on the certification for that number. So I had applicants that have come to me and I said, I'd like you to do a short field takeoff. And they plan for it. I said, what speed are we going to take off at? And they go, oh, we're going to take off at 70. And I go, why at 70? Well, because I said, see, if you're taking off and you have full power and 2 notches of flap, that's why Piper recommends, say at 20, I think I worked this out to about 2,200 pounds weight and 2 notches of flap. VS1 is 61. You can take off at 56. That's 5 knots below the stall speed. And people say, that's unsafe. That's not unsafe. The problem is that because of the condition now that you're taking off, the stall speed went down tremendously. Do we understand this? So same thing with the landing. Piper also gives you a different, this is used in big airplanes. It's called VREF. For every weight, there is an airspeed. In small airplanes, they don't go into the envelope is not that great, so they just give you 1. But you can, if you don't fly slower because you're lighter, I'll tell you one thing that you definitely don't want to do. You don't want to come in faster because you're heavier. Because that's when you get in trouble. Because 65 is your approach speed at gross weight. But if now, because you have 3 more people in the airplane, and you have baggage, and then you're going to say, well, I'm going to bump it up another 5 or 10 miles. You're setting yourself up for a landing accident, guaranteed. because there's no need to do that. If anything, you can fly a little bit, if you're not a gross, you can fly a little bit slower and shouldn't be any problem. VSO is a stolen speed if obtainable, blah, 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 with the power conditions set forth into paragraph C, which is the paragraph before, which is also at idle. The power is off. Propeller in the takeoff position, if it's a variable speed, constant speed propeller. Landing gear extended. Wing flaps in the landing position. Cowl flaps closed. Center of gravity aft. Legal limit. Center of gravity back there. And maximum weight. So if you're stalling an airplane and you don't, and the center of gravity is forward, like we normally do when we are doing our training, because it's only the instructor and the pilot, the center of gravity is where? It's forward. So that speed really doesn't coincide. So one thing that you want to start doing is, when you're stalling an airplane, look at the airspeed at which the airplane stalls. And then this will make a lot of sense. Now, what happens when a wing stalls? The whole wing doesn't stall. Remember, the stall begins at the root of the wing and starts working its way out. And the last thing that will stall is the tips of the airplane. Some airplanes deal with that with a twist. If you look at your 172, look at the last 1/3 of that wing is twisted. It's called washout. The name of that is called washout. So when the angle of attack here at the root is being exceeded, the tip is still flying. So you have your ailerons still that you can work. That's more or less how it looks like. The burble is at the root, and then towards the tip, the wing is still flying, so that gives you a little bit more control with the aileron. Now, when we're recovering from a stall, why nose down first and then power? Well, here's the thing. If you're stalled and you add power, you are now inducing a yawing action. Because remember, left turning tendencies? You add that power, you have now P factor going into place. You have now reaction to torque that wants to make the airplane go to the left. If you're in a stall condition and you do that, you go into a spin. That's why when you recover from a stall, you first lower the nose, get the airplane flying, and although that is done almost simultaneously, you want to make sure that the airplane is on stalled, not stalled, when you add the power, because you may set yourself up for going into a spin. All the airplane needs when you're stalled is some yawing action. And the power, as a matter of fact, when we fly an airplane that is hard to spin, hard to get into a spin, we use power to help us get into that additional yaw that we need to get into the spin. Now, you need to do stalls and recover with partial power, not full power. Just 17 or 1800 RPM. See what the airplane will do in that particular situation. You jam that power, something can happen, that wire can kink, and now you're not going to get full power. See, these are the scenarios. This is the what ifs of what can happen out there. How about no power? You stall, let it go. Do this at, you got to have some altitude to do this, because the airplane is going to eat up about 1,000 to 1,500 feet. But you see that the airplane is built to fly much better by itself than with us. They know exactly what they got to do. I will guarantee you that. We're the one to mess them up. They know what they got to do, but we constantly trying to make it do something else. And then do no recovery. You got no power and no recovery. Just let the plane fall and do whatever it's going to do. Always keep your wings level with the rudder. We covered that already. Now, power on stalls. Are there more than one? Well, here's what we have. We have the takeoff stall. Could be done straight, 10 degrees of flap, 20 degrees of flap, 25 degrees of flap, depending on the airplane, with gear down or gear normally done with flaps if required by the airplane, or gear down. In the case of a Cherokee, if you use flaps for a short field takeoff, you should do takeoff stalls with flaps so that you see how the airplane does. And then we have the departure stall, which what it does is also a power on stall, but now we're doing that in a turn. And that normally clean. Because when you're departing, you may get into trouble. There's some airports that you have a mountain in front, or some obstacles that you need to clear. And if you're departing and you're really not paying attention, you may get yourself into a situation where that's going to happen. So why do we perform takeoff stalls? And let me ask you this, and correct me if I'm wrong, but I'll tell you what has happened when you're doing the power on stall. This is what you do the power on stall. You're cruising, and the instructor says, well, let's go ahead and do a power on stall. What first thing we do, we slow the airplane down to about rotation speed, right? Because we're doing what? We're simulating a takeoff. That's what we're doing. We're simulating what this airplane will do on takeoff. Okay, so now when we bring the power back, but we need to maintain the same altitude, right? So we're going to kind of pitch up a little bit. We're going to increase the angle of attack to make up for the loss of lift because of the loss of airspeed. So now we're like this. And now you get to rotation speed, and you add power, and you start pulling on the wheel until the airplane stalls like that. That sound familiar? Well, here's what the problem is. Is that the way we take off? Well, see, we're training for something that we never do. And the danger about this is that now the relative angle is the one that is being imprinted all this time. But I'll tell you how the power on stall is going to happen. The day that is going to catch you by surprise is that day that you're going to go to an airport that is 4,000 feet high or 5,000 feet high. It's going to be 92 to 96 degrees. You're going to have all the seats full, and you're going to have your baggage. You're going to be at maximum gross. And you're going to be taking off from a short field. See, now you have all the ingredients that are conspiring to get you in trouble if you're not ahead of the game. Now you get in your airplane, and you add the power. You do everything by the book. You hold the brakes, you add the power, you let go, and the airplane starts accelerating. But now the airplane is not performing like it did in Lakeland or Leesburg, because the scenario is completely different. So finally you get to rotation speed, you rotate, because now you're loaded, your angle of attack is higher already than when you were practicing this just with your flight instructor, okay? So now you rotate, you're airborne. Now you see the trees at the end of the runway. And you say, wow, those trees are coming in quick. You know that if you pull, you're going to stall because that's what you did in practice. So what do? This is what you do. You just pull a little bit. Chit-chit. When you do that, unbeknownst to you, the airspeed starts to decay because you now are creating a little bit more drag. When the airspeed starts to decay, the nose is going to start to come down again, very subtle. And you're going to see the trees again. And you're going to say, oh my goodness, they're still there. And now you pull up just a little more. But unbeknownst to you, the first time you did that, you increased, for number's sake, you increased the angle of attack 5 degrees. In addition to what you already had. And because the nose came down, the angle of attack still there because your speed is less now. So when you do that again, the airspeed is going to decay a little more, the elevator loses effectiveness, and the nose starts to come down again. And now it's a vicious circle. And here's the thing, the nose will never be more than 12 degrees above the horizon. And you know for sure that you're not going to stall because when you were practicing the power on stall, the nose was up there about 20 degrees. And it's at that point when you do that last correction that the airplane goes, choop, and you're done. So the message is that when we practice stalls, we need to practice stalls the way they're supposed to. If you're going to do a power on stall, you pitch, listen to this now, you pitch to an attitude that will induce the stall. In other words, you should know what is the attitude that your airplane will stall power on. You pitch to that attitude and you hold the attitude constant by continuously increasing the back pressure. That's what we do. Because if we're climbing, or we're at 55 and we start that climb and we got that attitude, that airplane is going to go to the airspeed for that attitude. If that attitude is an attitude in which the airplane would stall, I'm going to get that airspeed indicator to continuously show me a slower airspeed. Actually, the rate at which that airspeed indicator should move, that needle, is about 1 degree per second. When you're doing this right, it's about 1 degree per second. Now, you're holding the attitude constant while you're correcting with the elevator to maintain that attitude. Because if you go like this and the speed is not enough to maintain that attitude, the nose is going to start coming down. So your job is to maintain that same attitude. And I guarantee you that that airplane is going to stall power on at a much lower angle, relative angle, than it did when you were not considering this, when you were just pulling this like this. I used to be 6'4". I kept bouncing the ceiling on the airplanes because we got over here and phew, and there I go. Now I just strap myself and all that, but it's too late. But anyway, here's the thing. You want the airplane to stall nicely. It's not a daredevil thing. It's just a procedure. It's a maneuver, but it's a maneuver that is done to really understand what your airplane is doing, to make you aware of where the edge of the envelope is. It's not to pass a check ride. That's the byproduct of it. You have to show it when you go on a check ride. But it's to really understand why my airplane stalls. Why am I doing this? You know, whoever put all these maneuvers together, they really knew what they were doing. I wish I would know of a single. I don't think it was a single individual. I think this was a combined effort about everybody. That it's like when you read that flight training handbook. By the way, you know, a lot of people feel that the FAA handbook is written by the FAA. Yes, it's written by the FAA, but you know, the inputs are from the industry. The Chuck Yeagers, the William Kirchners, the Rod Machados, the Barry Schiffs, the Robert Taylors, the people that have been the test pilots from Raytheon and North American and Piper and Cessna. Here's the thing. There are 50 ways to live your lover, but there's only one way to train to be a pilot. I'm not saying that there's only one way to fly an airplane. There's 1,000 ways to fly an airplane correctly. There's only one way to train. And why it has to be done right? Because it's been proven by research that in times of pressure or crisis, we revert to early learning. And if what you learned first was not right, you're going to revert to that. I mean, that's just the way it is. It's a human thing. To the point that they have taken these studies when the pressure or the crisis is real critical. It has been known for us to revert to the fetus position because it was the last recorded memory that we have of being secure. That's how bad it is. So we need to understand what happens when we do the stall. When we're doing a power off stall, why do we do the power off stall? Can anybody tell me the reason why we do power off stalls?
That's where you will be in landing configuration.
Okay, in the landing configuration. Can we be a little bit more specific? When your engine fails. That's why you train. A byproduct of that, it allows us to do a nice landing. But would you ever get into a stall if you have power on final? Can't. Because if you can't make the runway, what do? We have power. But if you have no engine and you feel you're not going to make the field, you may try to stretch the glide. And that's the key word right there. That's the only reason why we teach power off stalls, to keep us alive. Is that because that day that you lose your engine and you pick that field and you feel you're not going to make it, you may set yourself up to stall your airplane, but not in the same way in which you were trained to do the power off stall. Because power off stalls are done basically the same way as the power on stall, instead, with the only difference that we have no power and we have flaps. But when the pilot starts to stall, it's a continuous nose up until the airplane stalls and goes down. And that's not the way it's going to happen. The way it's going to happen is the reverse of the takeoff, but it's the same principle. You see the field and you know you're not going to make it, so you're going to pitch up just a little bit. When you pitch up just a little bit, you're inducing your elevator here to reduce the airspeed. And as that starts to happen, the nose is going to come down again. And it's going to give you that illusion now that you're still not going to make the field, but you already increased the angle of attack. Now you go again and you bring the nose back up again because you know you can't do this because that's what I did in training on my airplane stall. And every time you bring that nose up and the nose goes down again by itself because of the lack of airspeed, you're increasing the angle of attack a little bit at a time without even knowing it. And then it gets to that point where, boom, you're out of the sky. It's just that simple. So how shall we practice stalls? Here's the key that I'm going to give you. The key to practice stalls and get us close to the real world type thing is to do it with the shallowest relative angle. Remember what the relative angle was? The relationship of the longitudinal axis of the aircraft and the horizon. In other words, you want to deprogram yourself from that imprinting that you have, that if you can go as much as this and still you won't stall. No, you want to realize that you can stall on a power-on stall with an angle of about 10, 12 degrees. Now, how do we simulate that? Reduce the power. How would you simulate a high-density altitude airport, a heavy aircraft, and all that, short runway? Bring the power back. Instead of using full power, bring the power back to about 15, 1700 RPM. And then do the stall, and then you'll see more or less as close as possible what that angle is going to be. I believe we have come to the end, and I hope that this will bring, like I said, 1 hour. We can be talking here for 5 hours about this subject. I love this subject, but I think these pointers are really the important ones. You need to revisit your stalls training. You need to go with an instructor, but I'll tell you the best way to do that. Go to the book, the FAA Flight Training Handbook, and read where it's at. Read exactly how that stall is done. To conclude, and to drive my point home, do you remember how you held the wheel when you went for your driving test? 10 to 2? How many times have you done that since? Right? Now we use the knee, a hamburger, the girl or the boy, right? But if you're training someone or you're going to go for a check ride,